Today we're going to be discussing static electricity. So what is an electric charge? Okay, this is really important when you have static electricity because it's a buildup of these charges. Okay, so how do you produce charges on an object such as balloons? So normally a balloon does not have a charge, but if I rub it on your head or rub it on the carpet, it builds up of a charge. Okay, and then it can actually, or if I shuffle my feet on the carpet, I build up a charge actually where I'm not neutral anymore. I will build up an electric charge, and then this means that I have too many electrons compared to what my body wants, and so it'll try to do a discharge. Okay, but how do I get that electric charge? What it does is I pick up extra particles. I pick up these electrons typically, and so when you're walking across the floor, if I scrape my floor on the carpet, I will be picking up these electrons, and my body will become electrically charged as a negative. Okay, and what happens then is that you now have the ability to attract and repel different objects. Okay, how do you do that? Well, first off, if I was negatively charged, okay, I will repel anything else that is negatively charged. So if I have two balloons that are rubbed on the carpet and they're both negative and I try to put them by each other, what's going to happen is they will repel one another. Okay, I can attract them. How do I attract them? I put my negative next to something that is naturally positive. And so those will attract them. So if I put a balloon against a wall, I've got a positive and I've also got a negative. Okay, from the balloon. Now what happens is something a little bit different on this. It's not like the wall is actually positive right now. You make it positive, and I'll explain that in a little bit. Okay, so static electricity is the buildup of these charges on the material. All right, so explain what's happening below. Balloons just really like electrons, so they take them in very easily, so this is why it's an easy demonstration to do. But if you look at it, if I built up my electric charge by adding more electrons to it, by scraping it on the carpet where I picked up some of these free electrons, and I put it next to another balloon that I had done the same, you will notice that they repel one another. Okay, if I do it with a wall, what happens is that wall becomes positive and you'll notice that they attract. And actually, if you do this and you hold it up against a wall, it will stay against the wall and you do not have to do anything for that. All right, so we build up this electric charge, and what happens is that it doesn't like to be that, it likes to be neutral. So what it does is it transfers all the built up electrons from that I built up on my body, and it transfers it to whatever I touch. This is called a discharge. Okay, so like when I'm in my car, right, and I'm on the carpet, or not on the carpet, I'm on my car seat and things like that, and I build up an electric charge, I don't know it, but then I go and touch my metal door, let's say, I will notice that it gets a spark, and that spark is this discharge. What's happening is all the extra electrons that I have on my body will be going into the metal on that handle or the door. Okay, and then you will notice actually those electrons when you see those spark. That spark is the electrons moving from your body to the door. Okay, now electricity doesn't discharge in all the materials equally well, right? It definitely works better on a metal door handle than it does on a ping pong table, right? Or a piece of wood. So the reason why is because some things are known as conductors and other things are known as insulators. Conductors allow electricity to flow easily through material, so they love these electrons moving through them. Insulators, on the other hand, do not like this and they prevent electricity from flowing. So metals are considered conductors because they love that electricity flowing, whereas insulators do not love it flowing through it, so they prevent it. They do not like these electrons flowing through them, so they do not allow it. All right, so conductors, they allow electrons to flow easily. They themselves have loosely bound electrons within them, and they are free to move from one atom to another. You will notice that conductors are typically going to be your metals. And this is why when we have electrical wiring, we always make it out of these metals because they love to conduct electricity. I'm not going to use plastic wiring, right, to try to move electricity because plastic does not conduct. You want something that conducts and allows these electrons to move easily. Insulators, on the other hand, resist the flow of electrons. They hold on to their electrons. They're not like, they're like, I do not want your electrons. I do not want to give you my electrons. Okay, some examples are plastic, rubber, and glass. That's why when you have, if you ever do any wiring in your house, you'll notice that you have wire, right, which is made out of your metal, and this is where the electricity flows. Okay, but then it is always surrounded by plastic. And why? Because plastic is an insulator, which does not allow electricity to flow, which is really important when you have this wiring throughout your house, that you don't want the electricity to jump from the wire to something else. You want it to just go straight through the wire. So you surround it by plastic so that it insulates it and doesn't allow those electrons to jump onto something else, okay? Possibly cause a fire, also a loss of electricity, things like that. All right, so let's try to identify which one is a conductor and which one would be an insulator. Remember, a big key to conductors is you're really going to be looking for those metals. Okay, insulators will be ones that you don't tend to want electricity to go through. So the first one, wood, would be an insulator. A jar lid that is made out of metal obviously would be a conductor. A nail is a conductor. A rubber band made out of rubber is an insulator. A key, a very famous experiment done by Ben Franklin, was with the key, and obviously it conducted electricity. And a Q-tip, that would be an insulator. All right, so how does it transfer these static charges? How do I either build up my static charge or how do I get rid of it, right? Okay, and there are three main ways that you can gain a static charge, meaning a buildup of these extra electrons. So like if I were to look at a balloon, okay, how do I get these guys? Right now it's got positives and negatives, right? But how do I make it mostly negative? Okay, one way is friction, and friction is transferred from rubbing. So that happens when you rub a balloon against your hair or you rub a balloon against a carpet. You are taking those extra electrons and putting them from the carpet onto the balloon. Okay, that is friction. You are doing the motion, you are causing that friction. Okay, another way, conduction. Conduction is transferred by direct contact with another object. So if you look at this guy, which is the Van de Graaff machine, okay, you've got the Van de Graaff. What happens is with this machine, it literally throws electrons on the outside. It literally is connected to the wall, and it takes all of the electricity in the electrons, and what it does is it moves up, and this ball becomes so full of electrons. And if you put your hands on it, what happens is those extra electrons will now go from this ball into your body. Okay, so you become electrically charged. That is called conduction. And then induction is where you kind of have this force field where something is extremely negative, and by putting it next to something that's neutral, it actually pushes away all the electrons that are right there, and so it makes it kind of positive. This is exactly what happens with that wall. So if I looked at a wall, it's kind of hard to do on this page, but okay, I'll do it up at the upper right. So if I have a wall, typically I've got positives and negatives. This is my wall. Okay, it would be a lot more than I'm doing, but this is my wall. What happens is when I put my balloon next to it that I've already caused to be negative through, let's say, friction, what's going to happen is because electrons do not like to be by other electrons, these guys right here, if I move this balloon towards it, these guys will jump over to this side, which means now the positives will be over here. Okay, and so now if I do, this is my before, and now I do my after drawing, now I've got a balloon, right? It's got a lot of negatives on it, and now it's by my wall that force these electrons on the wall to move away as far as possible. I added a lot more electrons than I should. I should have only had 4 from the first picture. And now this is positive. So when you have something that is positive and something that is negative, what are they going to do? They are going to attract. And that is induction. Okay, that's what happens when you have a balloon with a wall and how it's attracted. So you have friction, you have conduction, and you have induction. All right, static discharge occurs, that's remember when you have a buildup of this static charge, but you don't want it. So what happens? It will try to get rid of it. It likes to be neutral. Okay, they want to neutralize themselves. They want to get rid of all these electrons. So how do you do that? Well, one way is, and this is the most obvious, which I'm going to skip. One way is sparks and lightning. So obviously you rub your feet against the carpet, you touch a doorknob, you see that electric spark, your body is losing its electrons to the metal, and then therefore you see that spark. Okay, lightning does the exact same thing. Lightning is that spark, except for it's just on a much bigger scale, right? So that's the one that you guys are most common for static discharge. Another way that you can do it is if with humidity. So humidity actually pulls off these extra electrons that build up. Water absolutely loves electrons. They love electrons. And so what happens is if there's a buildup of, I'm going to draw a water molecule. If there is a buildup of electrons, these water molecules will be like, I'll take you. And so it'll kind of like lower the amount of electrons that are available to then discharge to something else. All right. So hopefully you guys understand this a little bit about how static electricity occurs, how you build it up, and then how you also discharge it. So the two ways, basically remember is humidity, so you add water to it, or if there's humidity in the air, and then sparks and electricity. All right, have a great day.